Welcome everyone. In this video I'm going to talk about some updates and fixes for my coil winding project. So this is the sixth video of this project, and in the previous video I was talking about mainly the mathematics behind the winding and also the coding. So I already published the full and more or less working code, but there were some bugs or some mistakes in it. So I fixed hopefully all of them, and I also did some other improvements which were suggested by some viewers. So if you are interested in the source code which is located on this microcontroller, check the video at the corner because that is already published. I will not publish the code which is currently on the microcontroller because I still need to fix a few things and add some new functionalities. So that will come in an upcoming video, but here I will talk about these things. So this coil winder project is approaching its final, let's say, status. So I found most of the parts which I wanted to use in this project, and I more or less finalized all the wiring and the software and everything. So I think soon I will be able to publish everything as a package, so people will be able to replicate this thing in an easier manner. So this project actually involves a lot of 3D printed things. For example, the holders which I use on both sides. And then there is a spacer under this bearing, and then the main thing, which is the let's say tensioner before the feeder nozzle, and then there are also some corner pieces here which hold together basically this rail and then this U-shaped frame which holds the main shaft. And then this feeder looks something like this. So here comes in the coil from some, let's say, source, which is now here. It's out of focus, but you can see that I have the coil here, and then this is a sort of a real holder, and then the wire goes in here, and then it does a zigzag pattern and comes out here from the nozzle. So this is the 3D printed part. Wire comes in and then goes over this felt disc. There is a bearing here, turns back down here, there is another bearing here, felt disc again. So these felt discs are clamped together by another felt disc from the other side, so they provide some sort of friction for the wire. So at the end they provide the tension, and then at the end we have a nozzle. So as you can see, a lot of 3D printed parts are involved, and they are core or key components in this project. So this is a very good opportunity to talk about the sponsor of this video, PCBWay. So since this particular project heavily relies on 3D printing, let's look at PCBWay's 3D printing services. So in order to use PCBWay's 3D printing services, we have to navigate here and click 3D printing. And now we have this page available where we can select the files which we want to print, and this file has to be in one of these three formats. Once we uploaded the file, we can select the material and its properties, and basically that's all. It's a very simple process. We can click submit request and order our 3D printed material. And it's not only that PCBWay provides you the service itself, but they can also provide you some sort of literature where you can read about 3D printing and learn about 3D printing more. So in order to check those articles, we have to go back here and select 3D printing. And once we arrived to this page, we can see that they talk about how 3D printing works, and they summarize a lot of aspects of it. And then they talk about their own 3D printing capabilities, which consist of both metal and plastic 3D printing, as you can see. Then you can read about the tolerances, and you can read about the different materials that you can choose. And finally, you can read about further resources about 3D printing. So I think this is a very nice thing, because you can not only just order the service, but you can also learn about what you get. And you can also learn about how different techniques result in different kind of quality in printed material. So I hope that you like their services and all the things that they can provide to you, and I can promise that in the future I will introduce something even more exciting parts than just these 3D printed parts, where you can also use their services for this particular project especially. So coming back to this feeder part, so this is an identical part as here, already installed on the block of this thing. Finally, I got a part which is a very important part here, and that goes into this hole here. Now this hole is a bit too tight, so I cannot really push it in, but just believe me that this is inside there, so I have to drill it a little bit to make this slide in. So what is this? So previously I was using this guy as a sort of a nozzle, which is a copper, or more precisely a brass nozzle, used for 3D printers. So the hot plastic comes out on this nozzle and being printed on the surface of the heated bed. And this was okay in a sense that I could find a matching nozzle diameter for the wire diameter, so I could guide it nicely. But since this is like metal, then whenever I moved the wire through this nozzle, there was always a friction, and then the metal just scraped off the enamel layer from the copper wire, which is obviously not good when you are building a coil, because you can short your coil, and then you just built a pile of garbage. So then I found another nozzle at a reasonable price, because one of the biggest thing with these nozzles is the price. So we have this nozzle which is used for EDM, electric discharge machining, if I'm not wrong. And what that does is that what EDM does is it is cutting materials very precisely by making a discharge between a copper wire and the specimen, and then this discharge basically eats up the material which you want to cut very slowly, and then it cuts it very precisely. So this is the nozzle which guides the wire which makes the cutting. So how this nozzle looks like is that you have a stainless steel enclosure, as you can see, and then inside here, probably it's visible to some extent, there's this white thing which is a ceramic inset here. And then in this ceramic part, on both sides, we have a hole. And this particular thing, I don't know if it's visible from the reflections or not, but this particular thing has a 1 millimeter diameter here. And the one I use here with the nozzle built in the coil winder is 0.5 millimeters. And actually I found these nozzles in many different diameters, but I will use these because they are close to those wire diameters which I want to use. Here I use 0.35 millimeters wire, and then 0.5 millimeter nozzle is fine. So this end is flat, but this is so nice because here there is like a conical cut in this ceramic part. So if the wire comes at a slight angle, then the wire will be guided into the hole, and it will not touch any metal parts. So then the wire should glide nicely over this ceramic surface inside this channel, and that should allow the enamel to just stay on the surface of the wire. And also with the length of this thing, as you can see it here, we are somewhat closer to the bobbin. So when we are building the coil, we can move more precisely. So this is one of the big updates for the project. And of course, if you will visit my website, in the tools section, you will find these. They are relatively cheap. I don't remember the exact price, but below $10 per piece. So it's a quite okay price, and it's a good quality product. And then there was an issue when you try to build half coil from the beginning. So let's say this coil can accommodate 40 turns with this wire diameter, but if you just wanted to build 20 turns, so you just wanted to go to the half of this bobbin, then the feeder was continuing its way. And yeah, that was a programming mistake that I did. Here, what happens now is that everything stops at the same time, so I fixed that properly, and that was just because of some bad parameters, which was true, or which was correct when we wanted to build more than one layers. But if you just wanted to make one layer with this, and if the number of turns did not match the total number of turns, which would like entirely cover the bobbin surface, then that caused some issues. So that was one thing I fixed. And there was another suggestion that, for example, if you want to build a transformer, there you have like multiple layers of wires, which are the different windings for the transformer. And obviously, when you build these layers on top of each other, you want to separate them by some kind of insulating tape. So the request was something like this, that when you build a layer, you want the motors to stop, and you want to wait for a user input to continue the winding. So, for example, you finish a layer here, and then the shaft is expected to be stopped after finishing one layer, and then it should wait until you put the tape over the layer, and then you can continue with another layer. So I implemented that. I still feel a bit uncertain about it, but it works. So what I will do in this video is I will show these two software upgrades, like here, so I will show that it works, and then I will also try to make a coil. But I can already tell, I haven't tried it with this nozzle yet, but the quality on this reel is now quite bad, because I use this wire several dozens of times, so it is quite bent and damaged, but we will see. So let's start with the easiest issue, which is easy to check. If you want to go half layer, for example. So now this is a 14 millimeter width here, and the wire is 0.35 millimeters, which means that you can lay down 40 layers, or 40 turns to be precise, next to each other, and that will fill up the coil. So what I want to do is I want to have, let's say, 20 turns, because then the wire would go halfway. And I don't put the wire on it, so we just want to see if the motor goes in that direction as we want. So let's say I define 20 turns, and then I give the power supply to the motor, and then I just simply start winding. So I entered this menu here, and then I press the green button, and everything should go accordingly. So this turns this way, so if I watch it from my hand's direction, so this direction, it turns clockwise, and then this is coming towards me. So the coil is being built in this direction when it's being built. And it stopped in the middle. And here it's not visible too much, I think, but it writes that 20 turns are done. So the turns are done, and we are in the middle, so this works. And as you can see, it stops almost at the same time. I have noticed that there is still some speed difference between the two motors. So if you turn a lot of turns, it might be that the shaft is a little bit behind, basically just with 1 or 2 turns behind the speed of this. And according to the mathematics, it should not be, because the numbers check out, but still there is something, it's a real world situation, so we can introduce some magic numbers to the speed settings to match the two motors perfectly. So one thing is fixed from the checklist. So now I want to see something different. So now I want to show you something else. So I added a new menu item, which is called auto winding, and you can turn it on or off. When it is on, then until all the turns are completed, everything moves automatically. You cannot do anything except stopping it by pressing the red button. If you turn it off, then we have our new implemented function. The motor starts from the starting point, goes to the other end of the coil, and then it stops and waits for the user to press the button here, the green button. And then it will start moving in that direction, goes to the, let's say, starting side of the coil. So it finishes another layer, then it stops. And it does this until you finished everything. So now I have a funky number here for the number of turns, because I want to show you two things at the same time. And the number of turns is 130. So as I said, the width can be covered with 40 turns. So 40 is in 133 times plus 10. So we can do 3 back and forth motion. So 1, 2, 3. And then we go back 10 turns. So now what I can demonstrate here is that this stop and start function works. And I can also demonstrate that the last 10 steps or turns, sorry, so the last 10 turns are also completed properly. So I don't touch this, but I might speed up the video when this goes just in between the two sides. So now this is off. I go back to the coil winding menu, and then I just press start, and let's see what happens. So as you can see, the feeder moves towards me, and then the shaft turns counterclockwise if I watch it from my direction. And all we have to do, we have to wait until 40 turns, and then this should stop and wait automatically. So we are almost there. So now it's stopped, and here the message is paused. Press up to continue. So now we are expecting the user to press the up button, which is this one, and then this should continue its way. So I press this, and we see what happens. So the rotation is still clockwise, as you can see, but then the feeder started to go in that direction. So we wait again 40 another layers. And here we follow the layers and also the number of turns. So we see in real time where we are with the movement and where we are with the building of the coil. So now I see that we are at 68 turns. And we have 3 layers to do. So this is done. Again, it's paused. So I just have to press this button. Rotation direction is still fine on the main shaft. And then the feeder started to move towards me again. So everything is fine so far. And we have done already 120 turns. Which is also 3 layers. So 1 layer when we started, 1 layer when we went back, and the last layer, the third, when we came back right now. So now there is, like, let's say 1 layer left, so we have to put on the 4th layer, which consists of 10 turns. So the feeder should go in that direction, and it should stop at like 1/4 of the bobbin. So let's see what happens. So it stopped where we expected, and everything looks fine. And here now the software waits for another up button just to step out from this manual coil winding part. So now what we see here is that we have 0 layers left, which is correct. Turns done 130, which is also correct. And then the consumed length of the wire would have been 11.4 meters. So this is everything which I wanted to show regarding these updates. And now I will try to set up the system to try to wind some coil, but as I said, I cannot guarantee that this will work properly. So let me see what I can do. So I set everything up. I already finished the, let's say, programming here. So we will do again 130 turns, which means that we will have 4 layers, 3 complete layers, each of them will have 40 turns, and then 1 quarter layer which will have just 10 turns. And then you can see that I already have 2 turns here, and actually that is also programmed. So I manually have to do 2 turns to start the coil, and then the counting starts from there. So now actually the software will just do 38 turns, and then it will turn back, but backwards it will do the 40 turns. So this is what we have now here. All I have to do, I will, as you can see it on the left side of the screen, I have to hold down this reel holder. Even though it has this suction cup part, it doesn't work on my surface, my table's surface. So yeah, I can just hold it and wish for the best. So I just clean up a little bit, and then I will start the coiling. So yeah, I set up everything, power supply is on, and it's on the correct voltage. So we have to just press start. So let's see what happens. So I stopped this experiment because, as you can see, as the coil grows, it's perfect in the first layer, but the second layer is messed up. And I think I know the reason for that. So as I mentioned, the source for the wire here is pretty much destroyed, which means that it's quite dented and deformed, sometimes plastically deformed, which means that the diameter of this wire is not exactly 0.35. And I also mentioned this in previous videos, that this could be a problem, and you actually have to measure the real diameter. So the diameter which I defined here, which is 0.35 millimeters, is not so correct. So the real diameter would be somewhere around 0.38, I guess. And then the feeder would follow the development of the coil in a better way. So I might try to change that quickly and then return to you with another test. So I put everything together again. So I changed the wire diameter in the software to 0.38 instead of 0.35. So let's see what happens and how the coil is being built. So I just have to press start and see what happens. So as you can see, after the second layer is being started, there was some accident at this area, and that caused the whole coil to become messed up. And this also indicates that the diameter that I defined was still not okay, because I could see that the feeder was a little bit behind of the coil, and that could have caused some, let's say, crossing. So the wire was like forcefully pulled towards one direction, and the coil started to move backwards, which is not so good. But nevertheless, this is what I wanted to show you. So I have fixed the issue with the small number of turns, or the not integer layers. And then I added this auto winding function where you can stop in between 2 layers. And then I added this new nozzle, which hopefully helps the coil winding, because it does not destroy the surface of the wire. And since it sticks out, then let's say the source of the wire becomes closer to the surface of the layers which are being built here. Therefore, the guidance of the wire becomes better. But these are all the things which I wanted to summarize and show in this video. And in the next video, I will show you some quite significant updates. You will see it. So until that, please visit my website, curiousscientist.tech. You can find a lot of resources for this project and all the different steps. So I hope this video was useful. I hope you learned something, and see you in the next video.